Hello, how's it going, Marianne? You doing all right today?
I'm great. How are you doing, Austin?
Doing pretty well, doing pretty well. Thank you for taking time out of your day to meet with me and to just go over this really amazing demo that you did, you built. Um
Yeah, I'm super excited.
yeah, really excited. So particularly about this, what we're going to be discussing today is or what we'd like to for you to tell everyone about actually is the this pre-render demo that you built out on top of the Harper platform, and just yeah, wanted to just sort of hand it off to you, and would love for you to dive into that. But before we do that, want to know a little bit about you. So yeah, tell us a little bit about yourself.
Yeah, so my name is Marianne. I am one of the enablement engineers here at Harper. Been with the company for a few months now, just super excited, learning more about the technology and, everything cool we get to build with it. It's definitely fun.
That's awesome, man. And then just sort of diving into it, like the demo. So can you give us a little bit of just a background on why you built this out, this demo out, and what exactly like is it?
Yeah, absolutely. Before we jump into the demo, so basically this is a static pre-rendered template that we've built out for, we use it internally. We wanted to make sure, the public can use it as well to build awesome things. The goal is basically improving SEO for your website. So a lot of websites that use React and different, frameworks there, they can be kind of slow, all of that JavaScript running, everything that's got to load. So what we do is we pre-render that using a headless browser, which I'll get into.
Hmm.
So then we can store that static content and serve that from the edge almost instantaneously. So it just gives you a much faster experience from the SEO side. We serve it usually to, SEO bots. So then it helps with improving your search rankings, organic traffic, and you can also serve it to users to give them a faster experience. So just a really awesome tool to improve your performance.
And diving a little bit, well, first off, I want to ask, like, what? I mean, that sounds pretty intense. Like, what was it? Pretty difficult? Like, what?
Well, it wasn't just me. I'll say it wasn't just me. It
Yeah,
was
yeah.
definitely a team effort. So, but yeah, there's definitely a lot that goes into it. There's a lot of moving parts, as I'll show you. A lot of edge cases we have to consider. But yeah, definitely it's been a labor of love, as we'll say.
That's wonderful. That is really, really wonderful to hear. So yeah, as I said, yeah, let's go ahead and jump into it, and
Yeah,
love to,
absolutely.
yeah,
I'll go
love for you to.
ahead and share my screen.
All right, all right.
All right, perfect. So I'll zoom in, of course, to go into the details, but this just sort of shows high level. The way that our template is split up is there's two sections. We have the Harper component, and then we have the actual render service. And both of those pieces, talk to each other in order to make the rendering and delivery seamless. So basically, from the Harper component side, we have what we're calling our delivery cluster, which is basically a cluster of instances that have the Harper component running.
Mhm.
Each of those we consider a delivery node that runs a full Harper app within that. It's got, we've collapsed the stack. So you've got the app, you've got the messaging, you've got the database, which we show here. We've got two databases we're using for this, pre-render and local, which I'll have a bunch of tables that we'll go into in a moment. And then we also have one of the instances within the delivery cluster we designate as what we call our orchestrator node. And then that basically enables the communication with the render service. So with the render service, we have our render cluster, and each of those is a render node that handles the rendering. And that's just sort of the high level. We'll get into the details, of course, because there's a lot going on. Do you have any questions for me before I jump in?
Nothing yet. I'm just really, really intrigued by this. So as I said, please continue. Please continue. No questions.
Absolutely. Okay, so probably the easiest way to explain kind of how it all works is let's like walk through what a request looks like. So a client, makes a request to a page that will come to our delivery cluster. It'll get picked up by one of the nodes based on GTM routing. We'll put it to the closest edge node. And then that node will check our pre-rendered database, specifically the page cache table, to see if we already have the content available. And if we do, then it is immediately returned back to the client. And as I said, that's almost a near instant rendering then of that page. In the chance that we don't have it already rendered, we have an on-demand rendering pipeline that basically will create what we're calling a render job in this local database and assigns it to a render worker, which then gets trafficked through the orchestrator node, as I mentioned, so that it will get passed off to the render service, which I'll go into that detail in a minute. But once it comes back from the render service, it gets stored in the page cache table. So now for all future requests, it is instant. It's already been rendered and cached and then passed back through to the client that made the initial request. So that all happens extremely fast. It's all very highly performant, you know, seconds to sub-seconds in some cases,
Wow.
depending on how complex the page is.
Wow, that's really really interesting. And then I see a little bit further down we have an orchestrator node, and I guess I might be jumping ahead a bit and wanting to know.
No, you're perfect. That was
Yeah.
going to be my next step. I just wanted to
Okay.
pause in case, any questions that you had popped out. But yeah, so the orchestrator node is really a little bit of the magic that happens with the communication between the render service and the Harper component. So as we know, Harper has built-in messaging, and we utilize that in large part for this communication between the two clusters. So basically, whenever there's a new job that's available or a new render node comes online,
Hmm.
they make use of that messaging to register to receive notifications about jobs that are available. They also handle we have a shared array buffer that we set up so that way we don't have nodes trying to claim the same jobs. It, ensures atomicity when
Hmm.
the jobs are being claimed.
Okay.
So it also handles a lot of like refresh timing. So pages aren't stale. We make sure we have fresh content. So there's a lot of magic that happens here within this orchestrator node. Yeah, so then the next piece of this would be the render service, which we're using Puppeteer and their headless browser functionality, but really the way the template is set up,
Hmm.
it's really a bring your own render service. If you have a preferred, I know some people like Python, there's, Python services that you could you'd have to do a little bit of working, Python and JavaScript, but you could make that work if you wanted to. There's, quite a few different options. But like I said, we're using Puppeteer in order to render these pages. So we have the render cluster that's got these render nodes. Whenever a new node comes online, a few things happen right off the bat. We've got a worker that registers through with the orchestrator node that basically gets stored in that render worker table that I mentioned. So we know what workers we have available to assign jobs to.
Interesting.
And
Okay.
then we also have a queue that subscribes to the render jobs table through the orchestrator node. So then that way, when there are jobs available, it can signal for it to claim those jobs and start rendering.
Mm.
So
Okay.
once both of those happen, then the worker will launch that Puppeteer headless browser and start requesting jobs from the queue,
Okay.
which then it will fetch from the customer's origin and through the renderer, which, is got a lot of different configurations with Puppeteer and that you can set up depending on how you want the final output to look, will render that and then passes that back through the orchestrator to be stored in the page cache table.
That's really interesting. And overall, like just looking at the, as I said, both of these, the render service and everything, and like, what was the average like round trip, or were y'all able to like, do some like benchmarking or whatnot specifically around?
Yeah, so we've done quite a bit of testing because obviously we needed to figure out, what we needed cluster wise
Hmm.
for different customers and things like that. But so our benchmark testing is about 2,000 pages per minute for, your average kind of React app. If you have, a much larger page or a lot more JavaScript that runs and takes a long time, that might go down. Simpler, smaller pages that might go up. Yeah, generally speaking, we can get about 2,000 pages a minute.
Oh, wow, that is wonderful. That is really,
Yeah.
really, really wonderful.
So it's very highly performant. And like I said, even these on-demand requests that come in, if a client requests a page that's not already cached, that's happening in a matter of seconds as well.
Okay. Gotcha. Wow, that is phenomenal. And I'm trying to think here. Yeah. So
There's
I
a
mean, this
lot
is
to digest, I
it's a lot to
know.
digest, but I think this is like really really just well like just built out and everything like that. And so even when I like took a look at the repo as well too, I was like just when I had time yesterday, I actually looked further into it and I was just very impressed about just I mean with everything inside of it, specifically like around the I mean looking at the render service in particular and whatnot. And I thought I found everything the intricacies within that. It just all was very interesting. No, I'm actually this is very very cool. But yeah, what were the most challenging parts I think within building this out?
Yeah, so I would say a lot of the challenges came around, honestly, I think the orchestration, because there's, a lot you have to consider there with we're creating these jobs that need to be rendered. We are making sure that, each node is getting the work distributed, evenly. We have to consider, that atomicity of the database so that when work is returned, we're
Yep.
not duplicating efforts or losing, records in the process if we have writes trying to overlap each other. So there's a lot of that in the orchestrator node that we really had to consider to make sure that everything worked properly. And then also just performance in general.
Yep.
Sometimes there's easy ways to code things, and then there's less easy ways
Yeah.
that work better.
Yep.
There was, some iterations there of, maybe the
Hmm.
first time we did it, it wasn't the most performant. So, revisiting that, figuring out how we can fine tune things. Obviously you get little edge cases and bugs that you have to
Yep.
work through.
Yeah. I was
So all of those steps.
Yeah, I was actually just going to ask, like, in terms of like edge cases or whatnot, were there a substantial amount? I mean, again, I know this is going to be something that's ever evolving, right? That's not just a one and done thing, but were there a lot of edge cases that y'all had to like build out or, sorry, how to, I guess, compensate for, I should say. Um,
Yeah, there were definitely a few edge cases. So one of the ones on the render node that was probably the more recent one we had to kind of work through was the case where the render nodes were actually going through the jobs so fast, faster than they could claim new jobs. So in some cases, the render node would get the signal that, there were no more jobs in the queue, and it would stop even though it had just claimed additional jobs. And there was sort of that race condition of it
mhm.
stopping and it realizing there were more jobs. So we had to kind of look through, different ways some different listeners we could attach and things like that to make sure that, when that happens, it does start back up and doesn't just freeze. So kind of those edge cases. Another one would be, the timing of, Harper is very fast and very performant with rendering these pages, but what if the, client's or the customer's origin is slow and we have a client that's
Mm,
waiting for a request? So there's a little bit of, timeout logic there to make sure that
mhm.
if it is taking too long, we'd rather serve back 503 or some
I
sort of
see.
static error page just to
Hmm.
say, hey, something's not working right at the
Hmm.
moment. Try
Yeah,
back later, especially with SEO bots. You don't want that,
I
long
see.
time running and hurting your metrics.
Yep.
Serving back, say, a 503 tells it, hey, check back in a couple seconds. We'll have the content then.
I see. And then once a page refresh happens, the content will be everything's pretty much good for the most part, correct?
Yep, so it can continue rendering in the back end with the slower origin, eventually makes it to the page cast, and then by the next request, it's there instantaneously.
Okay. And for everyone here, first off, can we I want to like ask the repository actually, the repo.
Yeah, let's go into the repo for
Yeah,
sure.
let's go inside the
I've
repo
got
and
that
everything.
here. Yeah.
Yeah, so I see that we have the first folder, the Harper component, and then the second folder is the render service. Correct me if I'm wrong and whatnot.
Yep. Yeah, exactly.
Can we dive into like the orchestration? The I
Yeah.
guess the orchestrator node. I was gonna say orchestration node, but orchestrator node.
Yeah. So the orchestrator node that's within the Harper delivery cluster. So that's a little bit of a, so let's pop in there. So within the component, we have this local extensions orchestrator. And one thing that, people may wonder is why is this separate from the rest of the app? And
Yes.
the main reason is, Harper has the ability to have extensions and plugins. And so this was created this way with the potential to maybe use it in some future, pre-render projects. This is our static pre-render. There's some other pre-renders we could build
Hmm.
out in the future, just a little hint there that we might
Okay. All
reuse
right.
this again at
Okay.
some point.
All
So
right.
yeah, so that just starting why that's kind of separate. So it's got its own, package.json, config, all those
I
things
see.
that we need with Harper.
Okay.
And then yeah, we've got this orchestrator
Hmm.
module here.
Yeah.
So there's a lot of stuff going on. It gets pretty in depth, but the high level things I said, it's mentioning all of that messaging that happens. So we have,
Hmm.
a lot of, a little bit more complex callback logic, making sure that, especially with those on-demand requests, that we, keep track of which thread, which node made those requests, so we can get that back to the correct uh, client request. And we've also got, some logic in here. As I mentioned, we have that shared array buffer so
Hmm.
that we don't have nodes requesting the same work at the same time. They kind of get in line, first in, first out for that. You can see we have the topics here that the different render service nodes are subscribed to. So render jobs worker kind of works with that shared array buffer when it comes to request jobs. It claims what we call a mutex to ensure that only one is going at a time. There's a locking functionality there. We also have this job queue status, and that's where that worker is subscribed to the job queue. And when status updates happen, whether there are jobs queued or whether it's empty, can trigger it requesting to claim jobs. More of this. There's a lot of
It's a
callback
lot. Yeah,
thread
there's a lot. Yeah, there's like
logic.
you don't have to go through everything. I want to save
I'm
you
not
on
going to
that.
go
You
through
know, as
all
I
of that
said,
because
this is
there's
phenomenal.
that
Yeah.
would be a whole call on its
Yeah.
own. But
Absolutely.
we keep track
Yeah.
of the connected workers, as I mentioned, so we know who's available to
Hmm.
claim the different jobs. So there's some logic there. And
Okay.
then go down a little bit more. So this is one of the big pieces here, is this handle content. And so this would be when the worker has finished rendering the page and it's sending it back,
Yeah.
this is handling, making sure that gets stored in the database.
Okay.
There's some extra logic, like I said, that, get it back to the correct node and thread. But basically the meat of that is calling out to this save content. So we're getting the render job gets updated with a new status,
Hmm.
and the page cache gets updated with that new content. And then the last step that happens is we have a page meta table that we haven't touched on yet, but basically that keeps track of that refresh interval when these pages need to be refreshed. So that also gets updated with a new date whenever we add updated content.
That is wonderful. So, I mean, just as an overview, or just as a review of everything, like we went over like the architecture, right? Via the diagram that you showed. We dove into some code here, right, as well too. And well, last but not least, I'm really curious: is there like a demo we could, possibly take a look at? Is that possible at the moment?
We don't have a demo that we could show internally. That's actually a really great idea that we should attach to this. We are using it with several customers.
Yes.
I
Okay.
don't think we
Gotcha.
have permission to show
We
that
will.
yet,
Yeah. Well,
though.
let's not. Yeah. Let's definitely not do that. So yeah.
But yes,
No.
no, that's
No.
a
This is.
fantastic idea, though, that we should definitely follow up on.
No, this is wonderful. Yeah, like Marianne, like thank you very
You're
much
welcome.
for taking time out of your just your day to like to demo, give us like an overview of like this really intricate way of improving SEO. Right? Again, thank you so much, and I really appreciate this. So yeah,
Absolutely. I hope we get people using this and we get some feedback now that it's public, open to the community giving us feedback on things that we can do to make it better.
absolutely. Well, I think that's about it. I hope you have a spectacular day and a phenomenal rest of the week. Thank you
Thank you.
so
You too.
much. Thank you. Thank you.